Algebraic expressions, a collection of constants and variables connected by one or more operations of addition, subtraction, multiplication, and division. From this definition, let us see what constants and variables are. Constant. Constant means a symbol which takes fixed numerical values like 2, 3, or negative values like 14, negative 14, or it can be a fraction also 1 by 2, 3 by 4. All these are fixed numerical values and those are constants. Variables. Variables are symbols which can take various numerical values. When we say variable, it has to represent various values. So for this, we use literals to write. But what are these literals? Literals are nothing but alphabets A to Z, which are used to represent a unknown number. Variables in algebraic expression are represented with help of literals. Means when we say variable, it can be x or y or z or any of the alphabets or variables. Now we know what constant and variables are. We'll see how to write a algebraic expression. The statement says that it's a collection of constants and variables. So constant is a numerical value, say 2, and then we need to have a variable x or any other alphabet. So these two are combined with the help of multiplication, which we write as just 2x. So here we have used multiplication operation. In similar way, we can also write like 4x plus 5. This is also a algebraic expression wherein we have also used plus. This is only with multiplication, this is with multiplication and addition. And so on, we can write like any number of expressions, say 3x cube minus 4xy plus 6x. Here we are using subtraction, addition, multiplication, and even we have used two different variables x and y in this. Any number of variables can be used in a single expression. Even 7xyz, wherein we are using three variables, this is also a algebraic expression. So it is just a collection of constant, which means a numerical value, and variable. Variables are represented with the help of literals, that is alphabets. Terms. Now, if we observe any algebraic expression as 3xy minus 4y, in this we can see this plus and negative signs in between. So, these are terms are nothing but various parts of an algebraic expression which are separated by plus or minus sign. 3x square is one term, 3xy is the second one, and negative 4y, this is the third term. In this expression, we have got three terms. Let us take another example like 3x cube plus 4xy minus 6y square plus 6z. Even this we have got many terms, but how to say it's a term? So first thing is we look into where we have the plus or minus sign, and those things that are in between these signs are terms. We have four terms here. While considering a algebraic expression 3x square plus 4xy plus 6, we understood what terms are. But we observe here there is something which does not have any literal beside it. So 6 is also a term, but it doesn't have any literal or variable along with this. Such a term is called as a constant term. Means a term which has only numerical value is a constant term. Monomial. Monomial means when an algebraic expression contains only one term, then it is called as a monomial. Say 4x square. In this expression, there is no plus or minus sign. So this is only one term and it's called as monomial. Or simply if we write 54, even this is a monomial which has got constant term. 54 doesn't have any literal, so it's a constant term and only one term in this expression, so even this is a monomial. Binomial, when an expression has two terms, it is called as binomial. 3x plus 4y. So 3x is one term and 4y is the second one. Two terms, it's a binomial. Or we can say 5x square minus 3y. Even here we have 5x square as one term and 3y as other term separated by minus sign. So this is also a binomial. Sometimes if we get any question like 3xyz, we may get confused whether it is binomial or not. We shouldn't look into the number of variables it has got. We will just concentrate on the number of terms. And the terms that are involved in the expression may have any number of variables and the exponent can be anything. So here we have two terms. Though the second one has got three variables, it's fine. We will consider only the number of terms. Trinomial is when we have three terms in an expression, say like x square y minus xy square plus y square. This is an algebraic expression, and here again we have 1, 2, 3 terms that were separated by minus and plus sign. Polynomial is any algebraic expression which contains one or more terms. So all the monomial, binomial and trinomial, even these are polynomials. So anything we represent in terms of numericals or with the help of numericals along with variables, they are called as polynomials. While talking about polynomials, we have to concentrate on the variable very much. Like if the variable is in the denominator of, when we say expression like x plus 3 by y plus z. This cannot be a polynomial because here y is in the denominator. So we cannot have variables in the denominator. And any expression like x square plus 3xy power minus 1 plus y power y minus 2. Even this type of expressions where variables have negative exponents, those are also not polynomials. So in a polynomial, we can only have a variable with positive exponent. Factors. Each and every term in an algebraic expression is product of one or more numbers or literals. When we consider a polynomial, say 3x square plus 4xy plus y square. If we take this, I am taking the middle term 4xy. This has got factors like 4 is one factor, x is one factor, and y is one factor. So every term can be separated into individual factors wherein we will write the term as a product of its factors. Now among these factors, if we consider only the numerical factor, that is 4 here, it's called as constant factor, and all the literal factors are called as variable factors. In this case we have xy as a variable factor for this particular term. Now we understood what terms are and what are the factors and how to decide a numerical factor and a variable factor. Let us look into the coefficient. Coefficient in a term of an algebraic expression. Any of the factors along with the sign of the term is called coefficient of the product of other factors. Let us understand this statement with the help of an example. Say I have 3x square minus 5xy plus 6y square. Now coming again to the definition, algebraic expression, any of the factors. So coefficient can be any of the factors with the sign. So we have to include the sign as well. So that any of the factors including the sign is the coefficient of product of remaining factors. Now let us take this middle one because we have negative sign. We'll see how to include the sign as well. For this minus 5xy. What are the factors? We can write minus 5x and y. Factor along with sign. So consider any of the factors along with sign minus 5. This is the quotient of product of remaining factors. The remaining factors are xy. When we say what is the quotient of xy, we will say minus 5. Similarly, if someone asks what's the quotient of x, the remaining two factors are minus 5 and y. So quotient of x is minus 5y. Similarly, what is the coefficient of y? What are the remaining factors? Minus 5 and x. So, product of that minus 5x is the quotient of y. In this way, first we have to see what are the factors of a term and check for which product they are asking the question. Remaining factors together we have to take and write it as the coefficient. In this way, we have to write the questions. Now, what is a numerical factor in a term? When we consider minus 5xy, this minus 5 is the numerical factor and remaining two are variable factors. So when we consider only the numerical factor of a term, then it is simply called as numerical coefficient or quotient. Why we need to know about the numerical quotient itself is when we have a expression 3x square y plus 5xy plus y square, and the question is like what is the quotient of xy. So even here we can make xy quotient. In this term, if we ask what is the xy quotient, it is 3x. But when someone asks what is the quotient of xy, we just have to look into term where there is only a numerical factor other than what's asked in the question. So in this, we have 5 as a numerical factor other than xy. So we'll write 5 as the quotient of xy. When we are asking simply what's the quotient of something, we have to look into term which has got that value along with the numerical factor only. So in this way, we'll answer the quotient problems. Next, like terms. When we consider any algebraic expression, at times we may require to simplify this. This especially comes while doing addition, subtraction, or multiplication and division process. So we have to further simplify the expressions to give our answer in a way where we have unique terms like unlike terms. So what is this like term and unlike term while simplification? Like terms will have same literal factors. Say when we have 2a square b plus 3ab square minus 7ab minus 4ba square. When we check this, if we have to simplify this further, we should be able to write together the like terms. Like terms means they should have same variables. Along with that, even the powers of the variables or exponent of the variables should be same. Say AB and AB here. We have two variables. It doesn't mean that they are like terms. We have to consider the exponents of A and B as well. Here it is 2 and 1 for B. So this is not like term. This is not like term. The last one, if we look into this, A has got 2 as exponent and B has got 1 as exponent. While grouping this, we will write like B minus 4. I'm just rearranging this, A square B. The remaining are like 3AB square minus 7AB. We will simplify these two things further. A square B plus 3AB square minus 7AB. So when we say the simplest form of this algebraic expression, means after doing that we should have only unlike terms in the expression, we should not have the like terms. That is when it is simplified to the least process. So here now if we look into this, all these are unlike terms, means no two literals have got same exponents, same number of variables with the same exponents for each and every variable in it. So this is how we'll see which terms are like terms and which are unlike terms.